next one. Effortless interaction. That's actually a recurring theme. And one of the ways effortless interaction could occur is if the machines would know what you look at. Now, that's also, one of the scary directions, one of the very interesting directions. Google Glass is also monitoring your eye. It's not just that way, it's also that way. But how can we use that? We have an interesting example, again from Europe, of effortless interaction, which will be presented by Anders Bo Pedersen, IBM.
So today I'm going to introduce you to eye tracking in case you don't know what it is. I'm going to talk a little about the unique characteristics of this input modality. I'm going to show you a few use cases, and I'm going to also talk about interaction principles involved in this. Lastly, I'm going to show you a live demo of why we think this is a new input modality that is at least as good as touchscreen as you know it, as voice control as you know it, and many more things. So what you see here is a sort of classic eye tracking setup. You have a specialized piece of hardware that is able to see a user. From that, and with a bit of image processing, you are able to detect head, eyes, and lastly, pupil and glint. The specialized piece of hardware could be this. This is the eye tracker from my company, the iTribe, working for Windows and Mac, purchased from our webpage, that consists of simple sensor hardware. We have 2 infrared light emitters and a mobile camera sensor. That together with our unique software enables you to get data regarding where you are looking on the screen and also the position of the user's head. Simple stuff, but why is this good? What can this actually be used for? Well, the unique characteristics of this new input modality are just that, unique. Imagine being able to look at a device and not use a mouse, not use fingers to touch a screen, but instead totally and truly effortlessly just interact with it by looking at it. And that is why using eye tracking and eye control for this is truly effortless. It's intuitive to look at the object you want to interface with, and therefore eye tracking in nature is intuitive. Secondly, using eye control input is incredibly fast. You can look to the upper right corner to the lower left corner of a screen in nanoseconds. You cannot do that as equally fast with any other input modality. So what we think at this company is that eye tracking together with some new user experience paradigm creates a new input modality that we call eye control. And what we also know is that this is a totally new area, an area that despite the age of eye tracking in general is still not that researched. The basic UX paradigms of this area are yet to be settled. But what can it then be used for? Well, we usually talk about having some active use cases and some passive use cases. The active use cases are, at least in my eyes, get it? Very obvious. So you are able to control a browser, you are able to control anything that you would be controlling on a computer today using eye input, as you would normally control it with maybe touch or a mouse. So imagine scrolling a web page by merely looking down at the bottom of the screen. Or imagine an ebook reader where you turn pages by looking at the bottom right corner without using mouse and without using your hands. Another big area of active use cases is within the field of gaming. So the gaming industry are always looking of new ways to create fantastic user experiences, of creating fantastic games. Here, eye control could again be used as a new input modality, maybe strengthening the gameplay of a known game, or maybe creating totally unique and new games. Other active use cases could be, for instance, unlocking your phone using a pattern that you look at together with facial recognition. It could be building this into things that we know already, like smart TVs and car panels, and making you able to interface and interact with the car panels, for instance, without having to fiddle around whilst driving. And lastly, this technology can also, of course, help the elderly and disabled by creating unique interfaces that will allow them, the people that are not capable of touching a screen, to interface with the computer anyways. The other area of use cases I mentioned was the passive ones. Many have probably heard of eye tracking in regards to conducting usability studies, or maybe in regards to conducting research in general of user behavior. That is also a major field of this technology and will remain so with our tracker. But the passive use cases can actually be taken a step further. Imagine eye tracking running in the background while every one of you browses the web every day and just uses your computer. In these days where there's a lot of talk of surveillance and NSA, I don't want to say that we should all have eye tracking running in the background, but imagine the ability you would have to be able to customize, for instance, advertisement on web pages if you knew what a user had been looking at earlier. Also, today, much advertisement is paid per click. With this technology, you would actually be able to know how long you would have been looking at an advertisement. So maybe Google would in the future be interested in substituting that pay-per-click with a pay-per-gaze solution. That leads me to the interaction principles, because as I said, what you get from this technology is a point on screen, much similar to where you press with your finger. But how do I click? Clicking with your eyes have been, a difficult task to solve and will remain so. And that's because it's hard to do with your eyes only. Research have shown that, for instance, blinking to select simply doesn't work. When you forcefully blink as a human being, it strains your eye. You get tired. And furthermore, blinking is so fast that the hardware sometimes have difficulties detecting that you're blinking. So it's an error-prone solution. Secondly, you can dwell to select. Looking at an item for a certain period of time will then mean a selection. But if it takes around 800 to 1,000 milliseconds every time you want to click something, then it's tempted too slow, and again, you have an error-prone solution. Therefore, what we are researching at our company is using eye input together with the other known input modalities. So we want to create new user experiences. We do not want to substitute any input modality. We want to converge with them and create something completely new. What you see here is the tracker that I have lying here and that I'll be showing you in a second. The unique thing about holding a tablet or a phone is the fact that your thumbs are very close to the screen at all times. Why not use that fact? Since we are accustomed to touching the screen for selection, known from touchscreens, then why not combine that with eye input? So here we have an example where by touching the screen, we invoke a menu, and then we can look at the icons that we want to select. Letting go will then load that screen. I'll be showing you that live in a second. In other words, the input paradigms that we're working with is active areas in the bottom region screen, where we can either hold, quick tab, and we can use left and right mouse button design paradigms. Also, we can use these areas as joysticks. And lastly, we would, in theory, also be able to use them to do gestures and draw patterns. And this combined with where you're looking on the screen, you can create new and unique user experiences. So what we envision is that this new technology, or this new cheap technology, will play an important role in the future in regards to effortless interaction. We foresee that we'll see a whole new range of interaction possibilities, and we also hope, which is our goal, that we'll be in all the devices, all the mobile devices in a very near future. With that being said, let's jump to the live demo. So what you see here, is that the system is detecting me. Before I can do anything, I'm going to calibrate it. That's the demigods playing. Can we maybe turn down the projectors up here a tad bit? Thank you. Perfect calibration. Right, let me show you live the demo that I was just talking about. Here you see a browser. By looking down, I can scroll down. By looking up, I can scroll up. Most of you have probably seen this before. No biggie. But what we have implemented here is that by touching the screen, I invoke this menu where I can then follow links. Looking at something and letting go will then load that. Let me do that quickly for you. This is as fast as you can follow a link using eye tracking. So just by looking at it, touching the screen, that is far faster than letting go with one hand, touching the screen, or using a mouse. This is an example of some of the new possibilities. And I also talked about the ability to incorporate this into games. Let me show you a classic game called Fruit Ninja. This is usually played by swiping your fingers across the screen. As you'll see now, I'm blowing up fruit with my mind, and as you can see, I am not using my hands. So that was just a few examples of the many things that you can do with this. I could go on for hours where I think this will be used in the future, but this is some of the stuff that we at least are working on and what we are envisioning.
Thank you.
You're welcome.
Of course, this is huge. I mean, you think of slashing fruit games, my kids would love it, but for people that cannot use their hands, for what reason is this also excellent? It seems such a big development that you think it's not something that would come out of one company only, like iTribe. It's like all over the world people are working on this and trying this out. Is that correct?
Well, actually, the iTribe is made of high specialists within the eye tracking field. So the founders of this company are all PhDs within the area of researching eye tracking for low-cost components. Yeah. And that's why we differ from all other eye tracking companies, because this reference device that we created, we are a software company, and if we can create an eye tracking system for $99, imagine what the hardware manufacturers around the world would be able to do.
Exactly.
So our focus has been on cheap components from the start, and that is where we differ, and that's why we have a very small and specialized team.
Okay, and then you basically are B2B, you're going to convince all the hardware companies to buy your software to implement this.
That's exactly why we created this peripheral device that you saw me use just now, to get developers involved in creating some awesome use cases, so we eventually can convince the manufacturers out in the world to do a full incorporation.
If I look at this kind of really new technology, I think like, okay, these guys will be snapped up any moment by someone. Can we expect any big announcements soon? Or?
Well, I can't, of course, comment on that directly right here on stage, but let me say that in a world where phone developers are trying to differentiate themselves because all the phones are more or less alike today, presenting a new feature like this awakens a bit of interest around the world, so we are talking to many.
Okay. How many people are you? Where are you based?
We are only 15, as I said, small and very, very specialized team.
Okay, guys, wait. Next year it will be on all your screens. I have this feeling, at least. Thank you very much.
Thank you.